Okay, for today's video, I'm going to talk about the SNES programmer. We've made a few firmware upgrades, and so I wanted to talk about the features that this has. Also, I'm going to talk about some of the cart builds that I'll be using to test and kind of show and highlight. So, for example, this one here, this is an original high map 1J3M cartridge, and here I have 2 + 2 megabytes. And so on what this one is, this is the let me see. It's the mask ROM adapter, not this exact one, but you get the idea. And so on the ROM, it has two. See if I can get. So it's upside down, but so it's the two F1016s. And so, it's a 2 megabyte chip, which is a lot cheaper to acquire these days, and than the 4 megabyte ones. Anyways, but so this adapter, there's two of them. You can see them right here, and so this one has the ability to decode. See where it says 2 × 2 megabytes. So you bridge, that solder spot, and you don't bridge this one. And anyway, so this little decoder here will decode. You have to tell it, which half of the ROM you are. So if you're a 4 megabyte ROM, you have to split it into two chunks. So you have to tell it I'm ROM 1, I'm ROM 2, and then you stack them together. And then this little jumper here goes to the write enable on the SRAM. Anyways, so that's 2 × 2. It's 4, and so put it in the programmer, the power button, and then I'm going to get a USB window here. So let's see, I think I already have a game on this one. Yeah, I do. All right, so the programmer detects automatically if it's in high map or low map. It's a 1J3M, so it's high map. And so whether there's an SRAM file or not, it'll just dump whatever 64 kilobyte file it is, or kilobit. And so you can dump the ROM also, so if you want to erase a file, you just right click on it. You just go down and hit delete. Then it'll go through an erasure process, and then you can just drag and drop whatever you want on there. So anyway, so this one already has a ROM on it. So what I'm going to show you now is the SRAM. So we'll do programming in a second, but so this one here is Donkey Kong 3. So if I want to just dump the RAM contents, I can just drag it onto the desktop, from that window I showed you. But if I want to program a RAM back, then I'm going to hold this button on the back while I power it on. Okay, so let's see if I can do this with one hand here. So I'm going to push the button, and then I'm going to turn it on, and then you let go. So now the window comes open, and you're going to get this. Again, the programmer says, I recognize this as a high map. 0 kilobytes. This is just a internal function of the programmer letting you know that it's recognizing a high map cart. and then the cart SRAM here. And so I can delete the SRAM. Even if it's blank, it's gonna show up. And then over here, I already have a SRAM file from Donkey Kong 3 where I've completed all the levels. You just drag and drop. Okay, and then that should be written onto the cart. And so you can also write to OEM carts too. You won't be able to write the ROM to it, but let's say, for example, you change the battery and you want to keep your contents safe, so you can dump the contents of an original cart, something that has not been modded. Then you can change your battery, and then you can dump the contents back onto your RAM, for another 20 years of usage. But okay, so on this one, I did the DKC3 RAM. So I'm going to get to the screen here. And so there it is. There's my contents that I just wrote to it. Oh, this is the ending of the game, the other ending, I guess. I played this game when I was in my 20s, back when the Super Nintendo was out, and I loved this game. So kind of use it as my go-to game for testing because it was one of my favorites. So anyway, so that's that one. And then one of my builds is this. Now this cart here is a 1A3M, which means it's low mapped, but Donkey Kong Country is high map. And so this cart, I did the mod, the adapter mod, I guess you could call it, where it's converted to high map. So anyways, this one, you can't program these 27C322 ROMs through the programmer, just because these are not flash chips. But this is also one where I wrote the SRAM back to the game. So it's Donkey Kong 1. So there's my save, and so anyways, like for example, now these are the carts that I'm going to be selling and offering pretty soon. These come in a variety, like this is just 1 megabyte plus 1 megabyte. This is more for just kind of testing. And this is an extended rip map cart, 4 megabyte plus 4 megabyte. That covers just about everything in a standard cart configuration. Got your high and low mapping switch, which you have to program in low map if you're going to do a low map game. You can't just flip it after you've programmed. Anyway, so here's another extended high map game. So we'll do this one here. Sometimes my fingers are dirty, or sometimes I have to make sure you have good connections. Sometimes it takes a second too for it to kind of come up. Okay, where are you? It's been finicky. So the green light's on, it's doing something or thinking about it. So when the green light turns off, the window should pop up. Yep. All right. So, all right. So this one is empty because it doesn't show the flash.sfc. We can do a properties check on it. And it shows 6 megabytes free space. Okay, so what we're going to do is we're going to take Tales of Fantasia, just going to drag and drop. Tales is an extended high game because it's bigger than 4 megabytes. Anything bigger than 4 is an extended map game. And well, there's a lot of hacks that are bigger than 4, but 4 is the rarity. Or bigger than 4 is the rarity. So this is going to take a couple of minutes. So what I'm going to do is I'm going to just pause the video and then I'll turn it back on when it gets close to the end. So spared you from about 2 minutes of boredom. Green light's off, so everything's good. So you can just pull it out, or you can turn it off, pull it out. Either way, it doesn't seem to be a problem. So all right, so Tales of Fantasia, the English conversion, of course. So that's that. The cart can also take just a standard OEM game. Make sure you clean your edges, okay? These are not clean, but I'm gonna just show a few points. So on here, when you put an OEM cart or a non-flashable cart in, what you're going to get is you're going to get a mask ROM for the ROM designation. See, now this one, it recognizes a low map and a 2 megabyte game. So you could take this, you could just drag and drop it if you want to dump it, to your desktop or to your PC. And again, if you want to read the SRAM, you can just take the SRAM file and drag it to your desktop, to save it. But you have to push that button on the back, when you power it on, to write back an SRAM file. Okay, this is just a reading or dumping. And then the other thing I was going to talk about was, so if you get carts that don't have a map, in other words, we've got a mapping chip here, the MAD one, and my carts here also have mapping chips, here and here, and so the programmer looks at these chips to determine what map the card is in. Also, it looks what switch the position of the switch is in. But it's automatic, is my point. I mean, if it's in low map, that puts the cart in low map. Okay, and then when you put it in the programmer is going to look at the chips that are associated with low mapping, and it'll determine it for, you know, it'll basically confirm it's low map. But like, for example, this chip here, this is a chip with, it's just got a 2 megabyte ROM, and there's no mapping chip here or here. And I've made a couple of jumpers so it'll function as a non-mapping, you know, chip board. Okay, and so with these jumpers here, it's high map. But with the different set of jumpers, it could be low map. And so, so when I turn this on, I think it'll see high map by default. Yeah, that's high map, that's high ROM. So, but down here is a switch. See it? And so on this one here, like even if it's powered on, if you move this switch to a different mapping position, the programmer will automatically reset. So I'm going to put it in low map here. I'm going to slide it over. Well, slide it. So each time you change that position of that switch, it's going to change. So I told the programmer, I want you to be in low map mode. And so it's going to force it into low map mode, even though the way this chip is wired, or this board is wired, it's in high map mode. I'm forcing it into low map mode. And so, anyway, so that's this switch should be left in the off position, because, you know, for boards that have mapping chips, that because it'll be able to figure that out automatically. But you know, if you have a cart or board or build or whatever that doesn't have mapping chips, then you might have to, you know, force it to, you know, you might have to tell it, hey, no, this is a low map. Because without the mapping chips, the programmer doesn't know, and it's going to assume it's a high map game, but or high map ROM. So I don't have really a better example of that, unfortunately. But okay, so that's that is basically how this programmer works. I've got some bastard children here that I've converted into flashable, like the let's see, what is it? The 1A5B. That one's really a bastard child. And so, but you know, I've got a little adapter and my mask ROM adapter here, and I even have made a switch where you could change it from low to high and high to low. So, anyway, so this actually works almost exactly like this. It's just a little messier, that's all. Anyways, this is a 1A5B, which means it has a 256K SRAM, which also means that this mapping chip here is actually moved over like 2 positions, 0.2 of an inch or something, and which makes everything crowded, I guess you could call it. So anyways, the problem with the 1A5Bs, converting them, is they get in the way of, hold on, wasn't ready for this part of the video. Okay, so I got my little see-through tester here. So like the 1A5Bs, let's see, you know, they sit, you know, in a cartridge with these little tabs, you know, here and there. So what I did was I made this, I carved away the plastic on an ugly shell, you know, so I could see the tolerances inside. You know, like this side here, you know, it fits fine. But over here, because that chip's shifted over, you know, that post hits the circuit board. But, you know, if you have a 1A 3B build, you know, the 1A 3B, then it clears it fine. So, and there's the 1A 3Bs are plentiful, you know, and the you know, so which is why this board caters to the 1A3s instead of the 1A5s. So you can see there and there. So, anyways, again, it looks the same, but this board here is actually shifted that way just a little bit on the 1A3Bs. Anyways, it's the same thing though. Just this other one just has, you know, this other one just has larger SRAM, and I mounted a switch on it, but I can mount a switch on this one too, easily. But just kind of highlighting that. So, anyways, these are just like a flash cart. You put them in. You know, it's you know, it's going to see it as a high map, and oh, that's the other thing too. If you ever get a mask ROM message and it's 8,000 kilobytes, 8 meg, then the connections are not, they're not all being made. So that's kind of your telltale sign of, you know, check your connections, try again. So see now, after I kind of worked the connectors a little bit, now it says flash, you know, and 4,000 kilobytes. So, same board, I just, you know, work the connectors a little bit more. And so, anyways, it's probably dirty. It's a dirty environment. It's a messy desk. You know, there's all kinds of things going on at the same time. But anyways, I want to just do a video just kind of showing, you know, the programmer and a couple of the boards. Believe me, I could sit here all day and talk to you about different boards, but the primary purpose of this video is just to say, hey, this is the programmer, this is the firmware, this is what the switch does, this is what this other switch does, and so, yeah, I've got a loose connection here because the USB just reset. So, anyways, the programmers that I have are, this one's a little different. I used an original SNES connector here, and I've lowered this down. Normally, this is higher. It's above this, and you know, it's a little blockier, but I use this one for testing, so it's just a little easier. And so it'll look mildly different from the other ones, but you know, kind of look, you know, kind of like this, where the connector's below the, you know, top circuit board. Anyhow, I think I have covered all the features. The erasing LED is kind of a status indicator where it does short pulses and fast pulses, and that's fairly normal. I think when there's a problem, it'll either be turned solidly on, or I think there are other error indicators, but the main one is if it just stays on solid, then there's an issue. Try again kind of issue. And all right, well, that's it. I'm sure I'm forgetting something, but we'll figure it out.